The proofs, oddly enough, have been one of my favorite topics in geometry. I always saw them kind of like a challenge. Like when someone tells me to prove something wrong or prove it right, I was always the one to go for it. So proofs can be fun. And in this problem right here, we have a few things that we should master already. We have segments, we have perpendicular lines, which form 90-degree angles, of course. We have triangles and the definitions, as well as the theorems and postulates regarding their congruency. We have to know how to identify angles correctly, and of course, the definition of a parallelogram. If you're unfamiliar with any of these key terms, take a moment to review the definitions or look them up. These definitions are crucial for tackling proofs, which we'll use to our advantage. So we're given that segment MH and LN form a 90-degree angle. So let's identify that here. And we have that segment OI and LN form a 90-degree angle as well. We have segment MH congruent to OI. And we have angles HMN. So I identify HMN just in case you have a little trouble seeing that angle, is congruent to IOL. So let's identify that as well. So what do we need to prove in order to figure out that this LMNO is a parallelogram? We need to refer first to the definition of a parallelogram. A quadrilateral is considered a parallelogram if at least one of these is true. Well, first we need to prove that opposite sides are congruent. So we need to prove that MN is congruent to LO and that ML is congruent to NO. So that would be the first point. The second point would be to prove that opposite angles are congruent. So we need to prove that angle L is congruent to angle N, and that angle M is congruent to angle O. Another thing we could prove is that diagonals bisect each other. However, we don't have diagonals here going from one vertex to another. But we can prove the theorem, which states that if a quadrilateral has one pair of sides that are both parallel and congruent, then it is a parallelogram. So in order to prove that theorem, we need to say or state that MN is congruent to LO and parallel. And obviously the same would be true for LM and NO. So if we prove that LM is congruent to NO as well as parallel, we'd be good for the proof. And that is our target. Proving one of these conditions is true, or proving at least that the theorem is true. Now that we've organized our given information right here in this table, we can start solving. It's like solving a puzzle. First, you gather your pieces, then you start putting them together. At least that's how I always approach a proof. So let's start with these two columns. One, as you can see, can be or should be for the statement, and then the other we have for our reason. Our reason could be a justification, a definition, a postulate, a theorem. And that's why I mentioned the importance of knowing those concepts at the beginning, because we need them to establish our reasoning. Now, looking at this quadrilateral, we have 4 triangles inside the quadrilaterals, and they're all right triangles because the segments MH and IO are perpendicular. And based on the given information, we can actually confirm the congruency of 2 of the triangles. So according to the angle side angle postulate, we have that if 2 angles, these over here, 2 angles, and the included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. This tells us that triangle, let me get rid of those circles. This tells us that triangle MHN is congruent to triangle IOL. So by the definition, that means that since these triangles are congruent, the other sides, the segments MN would be congruent to OL. So first let's put this in our column proof. So we would say that triangle MHN is congruent to triangle IOL, and then our reasoning would be our angle side angle postulate. Now, we just said that segment MN is congruent to segment OL. So let's write that as well. We have segment MN being congruent to segment OL, and that would be because the corresponding parts of corresponding triangles are congruent. This is segment MN is a corresponding part of triangle, segment MN and segment LO are corresponding parts to each other. That would be established by the CPCTC, which states that corresponding parts of congruent triangles are congruent. Now that we've proven that one pair of opposite sides, which is MN and LO, are congruent, to complete the proof, we can either prove that the other pair of opposite sides are congruent, meaning LM congruent to NO. We need to prove that. Or we could use a theorem by showing that the congruent pair is also parallel. In fact, we can just do that. Segment MN is parallel to segment LO because they have congruent interior angles, which are angles, which is part of the given, which is angle HMN and angle IOL. So we actually just successfully proven that this quadrilateral is a parallelogram. So let's write that down. We have that segment MN is parallel to segment LO because we have congruent interior angles. So we can just state that LMNO is a parallelogram by stating that our theorem that says that one pair of sides is both parallel and congruent. Sorry for the abbreviations, but I just ran out of space here. So I really hope this explanation helps you understand a little bit of how to approach and solve proofs in parallelograms.